Uh, Thank you for everyone. So thank you for having me today. And actually, I didn't expect on my stuff I did every day is going to be present today, and this is my honor for me, and I'm really appreciate for the Praha for organizing this section, and thank you. So actually, my name is Toan. I'm SIE for the one company who have the office in the Berlin. And yes, so I'm also living in the Berlin. Today is I think I gonna tell you about a story instead of the presentation. A story about the event logging, and I will try to make it less boring than the other talk about the logging, because I know that there are so many presentations about the event, about the logging, about the chasing, and something. And I will try on my best. But before go through our slides, so I think I just want to let you know that I'm not the fluency advocate. So everything here is belong with my opinion. It's not belong with my employer, or it's not belong with my current company who I'm working for. Yeah, so that's all. Okay, so we go. Like every the story going to be starting. So one upon a time, there's one company who want to adopt with the SIE project. And I think nowadays you are less used to with the SIE methodology, say across us in so many organizations, like okay, SIE from the Google, and SIE when it come along, it will bring another definition about the observability, right? And in the observability, we used to talk about the three key point things. The first one is the logging, the second one is the tracing, the last one is the metric. It's kind of the so many kind of the metric or something. And because we are talking about the observability, so logging is a came along, and my company is actually, because they are not an exception, so they are also following with the SIE project. And yeah, so logging, chasing, metric is a came along to the picture. And yep, so we have the story about the logging. And as you know that for the every first day of the any kind of the company, the architect is a very simple one. We have the one monolithic where we put on the logic for our application there, and then so on the monolithic application running inside, we send log directly into the log cluster. And at that time is you know that we are just using the simple one like the ELK, because the ELK is a very popular one. Everyone know about the ELK. Everyone know about the Elasticsearch company. Everyone know about the Kibana or something else. And so they think that, okay, just put on the log into the log cluster like the ELK, and it will make you feel more comfortable to search the log, make the developer feel more comfortable to search the log or something. This is the good news, but the bad news is the simplicity is not always like that. And yeah, so my company is growing. My company is growing a lot, and we have a new customer. We have a lot of the profit. We have a lot of the revenue, and absolutely we have a new requirement. We have so many new requirements, and because we have so many new requirements, that's why we have adopt with the microservice. We don't have the monolithic service anymore. We're going to have a lot of the microservice. We decouple from the core function into the multiple of the microservice. And for now, as you can see on the screen, on the microservice is a send the log directly into the old log cluster. And I think, yes, it's not make sense anymore, because for now it's so many microservice. Some of the microservice is running with the Go language. Some of the microservice running with Python, or something else is running with the PHP, and it's sending into the log cluster. And yeah, so needless to say, it's broken. The log cluster is a broken. Broken here it doesn't mean that it's not reliable anymore. It's still reliable, but on the event in the log cluster is it doesn't mean anything. I mean, so many unmeaningful event collected, and yeah, it doesn't scale well also. And because the main purpose of the every kind of the logging system is to let all the people able to search and query the log from their application or from the other application. And because we have so many unmeaningful things in our log cluster, so that means no one is understand what is going on the logging pipeline, right? There's no one understand what will happen and why is my log event is got the indexing fail, or why I send the log into my application already, but why it doesn't show on our Kibana, why it didn't have anything to query, or every time when I query the field is not indexed properly or something. And yeah, we call that this year is broken. And that's what the time when I joined the company. So we actually were thinking that okay, before we implement the logging project, I mean we have at that time we call the name is the logging restructure project, and we are thinking that should we just go directly to the problem where I mentioned here, and then so we fit them one by one. Like example, if someone say that the logging system is a didn't scale, so okay, we can put that in the more scale. We put that into the Kubernetes. We have the more replica for the pod application. We use Elasticsearch distributed global searching or something else. And if we have so many unmeaningful thing event, so we can make our application log is a more meaningful. We put some monitoring system into our logging pipeline to let everyone to understand that okay, what is going on our logging pipeline. And yeah, because we have a monitoring system, we can monitor also for the indexing failure or something. That's the first thing. But the thing is, actually my team, the name of my team is a platform. And we actually don't think that okay, sooner or later, if we can fit the problem in the short term, in the near future, we might meet that again, and we want to leverage our logging application to the platform. And actually, if we want to leverage the application to the platform, it's also a challenge, because as you can see on the screen, we have also another question to tackle, to answer about that. Like example, okay, if you want to go to the logging platform level, okay, so how can you do the normalization, or how can you do the standardization for the on-log event? Even you know that on the log event is something from the Go language, some log event is from the Python library, or some log event is from the PHP or early C or something. How can you do that? The second one is okay, how to check on the operation which are happening inside your logging pipeline. How can you do that? If you this is the logging system, and you also need to implement the monitoring for the logging system, like the plastic, like the egg and the chicken, right? So how can you do that? And also the platform team, that means we create you can imagine that we create the playground for the other team. We create the one abstract layer for the other team to let the other team, to encourage other team to manipulate, to maintain our infrastructure with us. That means we need to distribute the core configuration to every engineer, to let them understand that, okay, so the logging pipeline will collect from the input 1, will normalize from the input B, will output to the input C or something like that. So the distributed, the core configuration is also very important. That's kind of the infrastructure as a code, right? I don't want to mention about this term, but because it's something like that, so I mentioned infrastructure as a code. Like somehow we need to variable for every the configuration to let the people understand that, okay, everyone can define into the YAML file. Everyone is a very easy to understand, easy to maintain or something, right? And the last one is okay, you leverage with the application, leverage from the application to the platform layer. That means sooner or later, there are so many applications will try to abuse your logging pipeline. So abuse, what does it mean? It means like example, one day when you see on your line logging cluster where it just intend to collect on the log from the line environment, it has some tag with the debug mode level. And some of the application, or they somehow they forgot to set the log level or log facility to be the debug or something worse than they set to the chase or something. And that means if we have the more log event sending to the our logging pipeline, we need to know that, okay, how can to control that? How can to have the proper throttling? How can to have the proper sampling to make sure that our logging pipeline will not be broken by one application? Because if it broken by one application, that means all the application will be unreachable, because it cannot send into the logging pipeline anymore, and then so it's caused to the a lot of the problem. And we we try to debate together, and the debate is a very polite one, not kind of the impolite debate. So we try to have several rounds of the debate, and we came up with the solution, something like that. So on the left side, this is the old architecture where we are using in the first initial time. First initial time, if we are using, okay, very simple one, because on our infrastructure is running on the Kubernetes cluster, and we run fluentd kind of the daemon set, and we just mount directly into the var host, something on the host layer, and on the microservice where it's deployed on the node, Kubernetes node, it can be collected and sent directly into the Elasticsearch. And from the Elasticsearch, we are using Kibana to visualize every log and let the developer who want to mask the log, who want to serve the log, is much more easier. This is the first one. This is the first architecture where we are using when we still belong with the monolithic. And then, so we are thinking that, okay, we want to restructure, okay, and we should divide our logging pipeline to be the three main components, as you can see on the right side. So the new one is actually have something different. We are using the fluentd kind of the daemon set. We are not using the fluentd anymore. We are using the fluentd kind of the daemon set and kind of the collector, where it's running on the every Kubernetes node. And the collector on the fluentd, I mean, as long as the Kubernetes cluster node is have how many in the node. So like example, you have the 100 of the node or 200 of the node, we will have the 100 of the fluentd instance or 200 of the fluentd instance, and all of them will send to the fluentd. And why we are sending to the fluentd? So the fluentd is the layer where we call the aggregator. And in the aggregator, we will try to put the something like I mentioned in the first challenging to leverage to the platform. We want to do the normalization. We want to do the throttling. We want to do the sampling. We want to do all the things. And we are thinking that, okay, the fluentd actually have the more feature than fluentd, because the fluentd intend to create a very tiny application where it just takes main responsibility to collect and sending. But in the fluentd, we need to have the more logic. We need to have another specific filtering to make sure that okay, the log data will be more meaningful. And the last one is we send to the Greylock. We don't intend to make it more complicated, honestly. I know you intend to ask me that why just sending to the Kibana or Elasticsearch, or just why do you intend to send to the Greylock? And from the Greylock, we use okay, AWS Elasticsearch kind of the backend, because actually Greylock is also using the AWS Elasticsearch for storing the log, but they create another abstract layer. And I will tell you the reason why we use the Greylock in the next few slides. And we also output the something we need to make more retention. I mean, longer than the other log we send to the S3, and because the S3 is a good place to store the something keep long. And yeah, so we have something like that. We agree together. We set everyone aligned in the same path. The reason is why. Okay, so I will go to a few technical technical where we use to tackle the problem for the leverage to the logging platform. So the first one, as you can see, I'm using the one email. I'm not sure you understand that, but basically this is the calling is a backpress view mechanism. The backpress view mechanism, that means if you know nowadays the people used to say that, hey, you don't need to collect on the log, or maybe you collect on the log and then so you send into the one queue and the Kafka queue or the NAT queue or something else, and the other application will try to consume the log from the queue one by one. But actually, the main reason is that we discover on the Fluentbit is Fluentbit is introduce one technical kind of the backpress view mechanism. The backpress view mechanism is mean that okay, it will use the tail command to tail directly into the log file on the host layer. Okay, and if it see that okay, I will have the file event, I will just finish the file event. I will output the file event into the Fluentd before I try to collect the new log event. So the backpress view, that means that it have the control like it's showing here. If it's more okay to get more the log to send, or if still need the time to collect the log, to process the log to send into our target. So yep, the backpress view is the main reason to use Fluentbit to send that to the Fluentd, because the Fluentd itself it didn't have, or maybe correct me if I'm wrong, but I try to see Fluentd have a feature like the backpress view, but it's just only have something kind of the optimize for the buffer or something. Even we know that the buffer, the output buffer is something similar like the backpress view, but backpress view is actually better than the using the buffer. Okay. The second one is throttling. Throttling is something is I already mentioned, like okay, sooner or later your logging platform is will facing with some application where the human mistake is happen. And actually from your side, you just also kind of the engineer, and all the engineers can make the mistake. And if they somehow they forgot to set their application log level, where it's going to be deployed on the live environment in the debug level or the chase level or something, you will your logging platform going to be flooded by so many the event. So we are using the throttling. The throttling, that means it will define some criteria to let you say that okay, I just only want to receive around 60 messages per second for the log facility with the info. And because this is the production, so it doesn't have any reason why you set the debug log facility for the production. That's why we just set for the 10 messages per minute. Okay, and similarly, like for the staging, we also have another numeric. For the chase, we also have another number. And testing cluster, okay, because this is the testing cluster, so we can have a bit more open, where we can allow to receive around 1,000 of the message per second. And please be aware that on this configuration is a specific for the application, not only specific for the whole cluster, because we know that some application may have some explicit requirement. Some application may have a different requirement. So we don't try to set for the whole cluster. We just try to set for the specific application. And in this case, yes, we are using the throttling to make sure that, okay, there is no application can make your logging platform is going to be broken. Is it? All right. So another thing is about the sampling. So sampling and the throttling is something similar, but it's actually completely different. So the sampling is something like, example, have you ever seen that there are so many repeatable events happen and send into your log cluster in the periods of the time, because the application is the log is a behavior of the application, and the behavior can be repeatable, right? So the sampling, that means I just want this is the way where you tell with your logging pipeline, where you tell with your logging platform is I just want to receive 5 messages with the same content during 2 seconds, during last 2 seconds, and any other message who has the same content in the last 2 seconds, please help me discard them. Please help me, don't collect them, just discard them. And on this thing is will be happen on the Fluentd side, not happen in the Fluentd, because we want to implement the Fluentd kind of the centralized, the heart of the logging pipeline. So sampling is something like that. And as you can see some example code here. Don't worry about that. I already prepared on the example code in the last slide for you. So you can try to grab that later. Okay, let's see about the sampling. And the next question is very straightforward. Like, okay, we are the SIE team. Okay, we take main responsibility to bring more observability for every team in our company. And because of that, we also need to understand what were happening inside our logging pipeline, what were happening inside our pipeline, because we need to like example, if I ask you like, hey, how many the log record can you collect per second? And how many of the record you can output per second? How can you answer for that one if you don't have the monitoring? How can you know about the log store capacity? Like example, the team A request to you like, hey, because my application log is a very important, I need to keep this log retained for the two weeks or something. If we don't count the log message size, if we don't have any the proper information, if we don't have the proper any indicator, how can you allocate the proper store for them, right? As you can see on my slide, okay, team A is reaching from the 1.4 terabyte on the 26th October, and until after 3 days, they reach into the 2.2 terabyte. And this is something like that. And you need to have the proper visibility on the whole logging pipeline, because it will help you to answer a lot of the questions. And also about the retention or the size of the message and how long you can keep the message or something like that. And to achieve this one, we are using the Prometheus Fluentd plugin and Flow Counter Fluentd plugin. I also have the example code for you later. Okay, this is about the monitoring for the logging pipeline. And the thing is, you are thinking that, oh, that have so many logic happening inside the Fluentd, right? And if you have any chance to work with the Fluentd, you will know that the Fluentd is running by the Ruby, and the Ruby code base, needless to say that it usually have something related to the performance. Because before I'm not biased, honestly. When I'm talking about that, I'm not intend to be the biased one, but I think the performance on the Ruby is have something we really need to think about that, because yeah, I think the performance is something. So that's why the Fluentd have introduced the multiple worker. So that means that for now, if you set up the Fluentd on your side, or you just spin up the one Docker container, you will see that the Fluentd pipeline will run with the one worker only. And that's why Fluentd is introduced. We can utilize the system with the multiple worker, because even that you run with the one worker, you grant for this pod is right. You grant for this pod around 4 GB memory or 2 CPU or something. It cannot be consumed, because the thing is it's just a kind of the thread, and then so it's only have the one thread inside inside your process. So that's why it cannot utilize on your resource allocation. And Fluentd is introduce the multiple worker, and with the multiple worker, it's actually span your thread, span your process into the multiple worker, and it can consume the more memory, more CPU or something else. So like I said, the quickness thing is strong as one, where the Fluentd try to improve. But there is one thing you need to be note about that one. is when you apply the multiple worker for the Fluentd, it's required on the Fluent plugin where you are using also support for the multiple worker. Because if you are not support for the your plugin is not support for the multiple worker, it cannot be run, and the Fluentd will be error because multiple workers are running kind of the isolation process. That means this process will be take responsibility for the input, output, throttling, sampling or something, and it's will the end to end. So that means the process will not sharing the result with each other. And if your plugin is just only able to work with the one worker, it will not know that, okay, so which were the result where I can use for this plugin. And you need to track that. So actually during the time when we implement with our system, because the output, as I mentioned earlier, is we output to the Greylock, and we are using the very old GELF plugin. It is standing for the Greylock log format plugin to send to the Greylock following with the VELF log format. And it's the plugin is actually didn't support for the multiple worker, but no worry about that, because we also patch the plugin to support for the multiple worker. So instead of you are using Fluentd to send to the Greylock, and you intend to have the multiple worker, apply multiple worker to boost your logging pipeline platform is a more robust or something, you can definitely you can use my plugin to do that. Okay, that's go for the multiple worker. And the last one, tackle for the thing where I mentioned distributed configuration. So let's imagine that, okay, everything now is in the Kubernetes, everything now is have the config map, and we put on the configuration inside the one config map. Is it make sense? No, it's not make sense, because every team need to have the take ownership for their own logging pipeline. I mean, we create the playground, but we need to let them to have the full capability to maintain their logging pipeline by themselves. Okay, and our responsibility is we keep this playground is always clean, always useful for everyone. So that means we introduce the distributed configuration, and luckily is the Fluentd introduce something like the include syntax. That means you can imagine that the team A can declare something like, hey, the input can come from here, the rate of the throttling is will be something like that, the rate of the sampling will something like X, like E or something, and the output, they can output to the S3 as they want. And if they want to output into the Greylock, they can also did by themselves. And our Fluentd main configuration will take responsibility to include on this config map, on this configuration into the core Fluentd, right? And the second one, as you well known about that, this is about the config map on the Kubernetes. Because for now, I know that we have some project about the reload every time when you change something on the config map, it will automatically trigger your pod will be reloaded. And we actually intend to apply that until the time we discover that Fluentd itself is able to do that by the enable the Fluentd RPC. That means Fluentd RPC will enable, will expose the one endpoint, and based on this endpoint, you can send like example, the curl command to say that, hey, let's reload this configuration, let's reload the Fluentd instance or something. And with this one, that means it makes sure that every time when the people going to change something in the config map, based on our CI pipeline, when the config map is applied, they will automatically reload the Fluentd to apply the new configuration. And the last one, using the utilize the config map and the mount point, because you know that we can mount the config map directly into the Kubernetes pod, right? But how about in scale, like example, we have so many teams, like example, my organization now is that we have around more 50 teams, and that means we will have 50 config map like that. And the thing is we don't need to create the 50 mount points to our pod container. We can have another solution to mount all of them to the one pod only. and mount on of the config map into the one pod, and from this pod is running the fluentd core application. It will automatically read on the config map from the on the team, and then so it will merge together. And now when we achieve that in the engineer now have the full visibility on the logging pipeline. Agree? All right. So I think I went so fast, right? Because for the few six from the sixth slide until now is around 12. In the sixth slide, I talk about on the thing from the our logging infrastructure. But do you think that enough? Do you think that the on this manipulation from the logging infra will be enough to make sure that the logging going to be the awesome pipeline to able to capture 100%? So if you are thinking that it is enough, so you are wrong, because we actually logging is something also belong with the developer. It's not only belong with the infrastructure team. And if we need to have the beautiful logging pipeline, we really need to cooperate with the developer. And the next slide will tell about that. So like I mentioned, we have from the first initial time, we have the one monolithic application. And now we have around more than 100 of the microservice. And the microservice is belong with the other team. And some team is they are very fluent in the Python. Some team is very fluent in the PHP, but some team is also very good on the Go. And the thing is that they will use the different SDK, or they will use a different library. And the way of that they are using is maybe different. But there's one thing we require to be unified together is the log field standardization. That means we define the one table, something like that, to define that every the field you should have in your log event to make sure that every the log field config is following with the proper format, with following with some meaningful information. Like example, customer ID, I want it should be the string. Order ID should be the integer. Chase ID it should be the numeric with some float or something. Upstream is absolutely should be the string. And log field standardization is something like in our official documentation where we release for every team. We said that, okay, because for now we are not very veteran enough to be the release every logging library for the Go, for the Python, for the PHP, because we know a lot of the people better than us do that. So we don't intend to do that, but we define some log field standardization, and we hope that you can follow with that. And we release this documentation to share across to our organization. And yeah, because we're sharing with the developer, and the developers they always have a different point of view, different perspective with the operation people. So they can follow, but in the worst case, they won't follow. And what if they don't follow? So you know the well-known issue, right? If you are sending example, you are owner of the application A, and inside the log event of the application A, you have the one field kind of the customer ID. And if we absolutely follow with the string, and it's good, it's sent to the Elasticsearch, it go to the fluentd, it go to the Greylock, and Greylock is able to index it into the Elasticsearch. But the thing is, we also have the application B, and the application B is have the customer ID where it's not string, it's the numeric one, or it may be the integer. And the thing is, if the application B log event is coming first instead of the application A coming, so the log event, the Elasticsearch will assume that, okay, the customer ID field will belong with the numeric one, and it absolutely will reject on the method from the application A, where because the field is belong with the string, and because this field is already numeric, so I'm sorry, I cannot index you into our logging pipeline. This is something like that. And I think this is a very well-known issue of the Elasticsearch, well-known. Okay, and we are thinking, so how can enforce the developer? Even we don't really want to do the enforcement or something. We don't really want to do that because we believe on the capability. We believe on our developer mindset. Either they will follow with us. But the thing is that we still need to be the enforcing. Even that we still able to checking down what were the method not following with our standardization, and then so we can come directly to talk with the owner like, hey, your logging format is not correct one, can you help me to change that? And then so they will okay, they nice enough to okay with you. But the thing is that they will have the less priority for this task. They will priority for the other task because there's no one thing. I mean, they are just thinking about the logging when the application is have a problem. Agree? When the application is running smoothly or something, they will never go to our logging pipeline to see what were the behavior of the application. At least in my organization is something like that. Okay, so we implement the one Lua scripting running sidecar. I mean, it's not kind of the sidecar, but it's running side by side with the Fluentbit. And the reason we running in the Fluentbit and not the Fluentd, because the Fluentbit is a tiny application and it's allowed to run for the Lua script. And based on, because we will have the multiple Fluentbit instance, but we just only have a few Fluentd instance. So we want to share the workload. We want to share the workload, the filtering workload with the Fluentd. And we are thinking that Fluentbit is a good layer to say with the application like, hey, your application is not following with the format, go away. And we do the filtering by Lua. And I also have an example code for that one, so no worry about that. And yep, let's see the story with the Fluentd, and I will try to answer for you first about why we choose Greylock and not choosing the just sending directly into the Elasticsearch or something. The first one is about the authorization. I have to say that we actually try to, you know that in so many cases, there are a lot of the case where the information, the sensitive information will be locked on our application. And some of the application, we don't really want to let the other developer know. I mean, just only the people who take main responsibility for this application know about that. So we want to do the proper authorization. We want to do the proper, everyone need to log in and everyone need to have a specific explicit right permission to access into our log, because we believe that the log event is more important than ever. Because there is no way to make sure that you don't expose some sensitive information on your log event. Okay. The second one is the observability from the UI. So the thing is that when we are using the Greylock, we know about the Prometheus monitoring for the Greylock, and it's exposed so many meaningful magic where it helps you to do the proper observability for the Greylock system. And based on this one, you can absolutely know about some people just query about something and somehow it return not found, or somehow it return proper information. And we really want to know about that. We know it's not because we want to harass or something. We want to know because we want to improve our experience. We need to know that, okay, during the last 2 hours, how many of the queries are already successful and how many of the queries is unsuccessful. And we are pretty good with the observability for the Greylock because it provides a lot of the useful information for us. Okay. The third one is an abstract layer for the Elasticsearch. So actually, Greylock is something very similar like the Elasticsearch. Like it's also using the Elasticsearch for the backend, but it's create another abstract layer in front of before arriving into the Elasticsearch. And this abstract layer to help us a lot of things. Like example, we can config like how many the retention for this application, how many the method you want to allow for this index set, or sometimes you have so many index and index, you want to delete that because it's quite a long time ago. So how can you do that? And I know that you also have the problem, the solution to solve that. But actually, the Greylock is a bring up the more visibility and more useful way to do that. And the last one is manipulate the data. So you will ask me that, hey, you already did so many manipulation on the Fluent bit side, on the Fluent D side, but why do you still need to do the manipulate the data on the Greylock? So actually in our use case, we need to do that because let's say that there's some application and the method field on the log event is have so many the JSON nested inside, and they want to pass on the information and they want to filter based on the some field inside this method. And we actually thinking that, okay, Fluent D can do that. Fluent Bit also can do that. But the main thing is a Fluent D and a Fluent Bit is something for the another responsibility. One is for the collector, one for the aggregator. And the Greylock is something like the end-to-end application to extract that one. And we don't need to put so many logic for our Fluent Bit, Fluent D because they are already overloaded. So we don't need to make it more busy. So and manipulated on the Greylock side, that actually will bring you more, how to say, easier than using on the Fluent Bit and Fluent D. Because if you well known issue with the Fluent Bit or Fluent D, you will know that the way of the you write the query or something is cost you a lot of the effort. But if you write everything query on the Greylock, and actually we also have the Greylock Terraform provider, you can do everything under HashiCorp code language. It will much more easier for you to extract the data, and then so you will less headache about that one. So that's really the four main important key where we are thinking that, okay, using the Greylock is better than sending directly into the Elasticsearch. And this is the last one. Okay, so we already mentioned that we have this one. We have monitoring for the logging pipeline. We have everything to make sure that our logging not broken. But the last one is define the proper SLO, the service level objective for our logging pipeline and from the for the logging pipeline. So from the end user perspective, like example, everyone can be the end user. And end user perspective is they want to have the 99.95%, I mean finite query should be returned properly. But from the developer perspective, they want to have something like, I want to know that in the last 2 hours, 99.95% log event is indexed properly. And we actually able to do that. Like I mentioned, we are using the Prometheus monitoring. We also have the other Greylock monitoring, and we able to do the calculus based on this one. And this means from the end user perspective, we turn to the from developer perspective. And yeah, so that's the on about the journey. It's not a long journey because I actually implement that during last 4 months, and it bring a lot of the trust from the developer because they are, when they lose the trust with the logging pipeline, because they said that I never able to find any the proper event on our logging pipeline. But for now is they happy with that. They able to filter, they able to sort, they able to do any the data manipulation for the log event, and we leverage more with that because the platform logging event is not only provide for them, but also provide for the data team where they can know exactly about the some specific information, and it's kind of the event driven data. And because we try to make our event is more meaningful, that means we try to we bring more the visibility for everyone, and it's achieved and it's successful. And so that's all. I think that's on the thing where I want to mention. You can discuss directly with me on the Telegram channel. I used to chat in the Get Hangout, and on the slide on the example code, you can go to the talk.finget.me. My Twitter is the Patriot VN, And the last one is that I hope I know we have so many logging presentation about so many the cool thing, so many the lag thing like using the Elasticsearch, Kafka, Buffer, Queue, or something. But what I want to say is that everything needs to be tackled from the end user perspective instead of the trying to have so many the technical or have apply so many the technology, but you don't really know about that one. So try to be log well and live well. That's all. Thank you.